Today, we're going to pull back the curtain on something that pretty much powers your entire online life, but you probably never even think about it. We're talking about a fundamental difference in how databases store your information. You know, the ultimate showdown, rows versus columns. So let's just start with a question that I think we've all felt. Why is it that you can pull up your last bank transaction on your phone instantly, but that big chunky sales report at work takes what feels like an eternity to load? The answer, it turns out, is hiding in plain sight, right in how that data is stored. And that's exactly what we're going to unpack. And to get our heads around this, we're going to use this simple employee data table as our little case study. Super straightforward, right? It's got IDs, names, salaries, the usual stuff. We're going to run a couple of tests on this exact table to see how these different database types handle the pressure. Here's the game plan. First, we'll dive into how row-based storage works. Then, we'll see what's up with column-based storage. After that, we'll put them in the ring for a head-to-head showdown. And finally, we'll figure out how to pick the right player for the right game. Okay, let's get into it with our first contender, the row-oriented database. I like to call this one the transactional champion, and you'll see why in a second. So, what does that actually mean? Well, it's pretty simple, really. A row-oriented database stores everything for a single record all together. So all the info for employee 1, their name, their SSN, their salary, it's all physically sitting next to each other on the disk. The database literally thinks horizontally. When you ask for a record, it just finds the beginning of that line and reads straight across, grabbing the entire row in one single move. It's just like reading a sentence in a book. So let's give it a challenge that plays right to its strengths. We're going to ask it to select everything, all the data, for the employee with an ID of 1. And boom, it's incredibly efficient. Because all of that employee's data is packed together in one spot, the database just jumps to that location and reads the whole block. It's a lightning-fast, one-and-done operation. But what happens if we switch gears? What if we ask it to do some analysis? Let's say we want to calculate the total sum of all the employee salaries in the whole company. And this is where it just completely falls apart. To get just the salary for each person, it has to read the entire row for every single employee. The ID, the name, the SSN, everything, just to find that one little piece of data it actually needs. It is a massive amount of wasted effort and I/O. Okay, so now let's meet our second contender and see how it tackles the problem with a totally different approach. This is the column-oriented database, the analytics powerhouse. With this one, the logic is completely flipped on its head. A column-oriented database stores all the data for a single column together on the disk. So you've got a block with all the first names, another with all the last names, and you guessed it, one tidy little block with all the salaries grouped together. This means the whole way it thinks is vertical. It's built from the ground up to scan a single attribute, like salary, across millions or even billions of records with unbelievable speed. So you know what's coming. Let's give it that exact same analytics challenge. Go find the sum of all the salaries. And it's just blazing fast. Because all the salary data is sitting there together, the database just goes to that one block, reads only what it needs, and completely ignores everything else. No wasted time on names or titles. This is its absolute superpower. But what about that first challenge? You know, the one the row store totally aced? Let's ask this one to fetch all the information for our employee with ID 1. And yeah, this is its Achilles heel. To put that one employee record back together, it has to do a ton of work. It has to jump to the ID file, then jump to the first name file, then the salary file, and so on, picking out one little piece from each place and then stitching it all together. It's just a lot of jumping around. All right, so we've seen them both go a few rounds. Now let's put them head-to-head and really lay out the pros and cons. What's so fascinating is that their strengths are perfect opposites. Row stores are built for writing data and for retrieving entire records really, really fast. Column stores, on the other hand, are absolute beasts for huge analytical queries. Oh, and another cool thing about them, since all the data in a column is the same type, like all numbers, they can use some seriously powerful compression tricks to save a ton of disk space. And this fundamental difference leads us to two classic industry buzzwords. Row-based systems are perfect for something called OLTP, or online transaction processing. Think of your ATM or an e-commerce checkout. Databases like PostgreSQL are great for this. Column-based systems are built for OLAPE,
or online analytical processing. Think business intelligence dashboards powered by massive data warehouses like Amazon Redshift or Google's BigQuery.
So, you see, this was never about one being better than the other. They are highly specialized tools, and the real secret sauce is always, always matching the right tool to the job you're trying to do.
And that really brings us to the core takeaway. For any app that's doing a lot of reads and writes of individual records, get me all the info for this one user. A row store is your champion, hands down. But for any system that's designed to ask those big, sweeping questions across millions of records, like what's the average of this one thing, a column store is absolutely the way to go.
And all of this leaves us with one last big question. As we generate more data than ever before and we demand both instant transactions and deep, powerful analytics, what's next? What does the next evolution of database design even look like? Is there a future where we can truly get the best of both worlds?